Solutions. Solutions are a type of homogeneous mixture in which components are uniformly intermingled. The atmosphere is an example of a solution, but it's a gas solution where it's a mixture of oxygen, nitrogen, and other trace elements. Aqueous solutions, which we have talked about before, is when substances are dissolved in water. Solution composition. Well, there's two parts of a solution. One is called the solute, or the substance dissolved. The other part is the solvent, which is the substance that dissolves. A solution is composed of the solute plus the solvent. In this case, we can see that salt, NaCl, is being dissolved in water. In this case, the water is the solvent because it's doing the dissolving, and the stuff that is being dissolved is the sodium chloride. Solubility depends on temperature. There's three terms I want you to know: saturated, unsaturated, and supersaturated. Saturated is a solution that contains as much solute as possible at that given temperature. Unsaturated is a solution that has not reached the limit of solute when dissolved, and supersaturated, sometimes when a solid is dissolved to the saturation limit, all the solid remains dissolved past the saturation point. Here's an example of the solubility curve. If we take a look at, for example, potassium nitrate, this line represents the point of saturation. Above the line is super saturation, and below the line is unsaturation. As we can see here, in general, here's our solubility, okay, the amount of grams in solution in terms of our temperature. In general, as we increase temperature, so does the point of saturation. So the other factors that affect the speed of solubility, obviously, is particle size. Small size equate to large surface area exposed to the solvent and easier to dissolve. Stirring continuously exposes more surface area, therefore dissolving happens a lot faster. And obviously temperature. Solvent particles move more rapidly in higher temperatures, thus increasing the dissolving process. Mass percent. This expresses the mass of a solute present in a given mass of solution. In this case, here is our formula. Mass of solute over mass of solution times 100 will give us our mass percent. In other words, our grams of solute divided by the grams of solute plus grams of solvent times 100 will give us our mass percent. Here's an example problem. Suppose a solution is prepared by dissolving 1 gram of NaCl in 48 grams of water. What is the mass percent of NaCl? Well, we take 1 gram of solute divided by 49 grams of solute, 1 gram, plus the grams of solvent, which is 48 grams, equals 49. And when we do that, we should get 2% sodium chloride. Molarity. Molarity is the amount of solute in moles per volume of solution in liters. This refers to the concentration of solute. Okay, so it's not the same as mass percent, but it's on the same lines. The higher the number, the more concentration of the solute. Here's our formula. Molarity equals moles of solute divided by liters of solution. Molarity refers to these units, moles per liter. Okay? We often denote it as a big M. Here's an example problem. Calculate the molarity of a solution prepared by dissolving 11.5 grams of solid sodium hydroxide and enough water to make 1.5 liter of solution. First thing we need to do is find moles of the solute. Okay, and we do that by taking 11.5 grams and dividing it by its molar mass, and we get 0.288 moles of sodium hydroxide. Then we plug it into our equation where molarity is found by dividing moles per liters, and we get 0.192 molar solution of sodium hydroxide.